Hey, boys and girls, happy Tuesday. Today is March 9th, and we are back again for day 7 of Number Corner, where we are going to spend most of our time on a problem string. Before we do, I just wanted to show you today's calendar marker, which it does look like it's following the same rule of adding 3 to the output from the day before, and we're still trying to figure out what the program is. So if you think you know, awesome. Write it down so you don't forget. Hold on to it. Tell your teacher. And maybe by the next time we talk specifically about calendar grid, then everyone will have found the program for themselves as well. We're also going to update our calendar collector. So that means we're spinning for today. So the first spin is yours, which it looks like, is it on the line? It looks like it's more pointing towards 1/3. So your spin is 1/3 and my spin is 1/6. So I'm going to add that to our recording sheet here. And 1/6 for me. All right. Now on to our problem string. So if you would open up, you have a blank clock page in your Number Corner student books. You can get out some colored pencils or crayons, or maybe you just have a pencil, which is fine with me. And we are going to talk specifically about equivalent fractions today. Do you know what an equivalent fraction is? Fractions that are the same. They take up the same amount of space in reference to the same whole. So I do need to point that out, because if I'm talking about half of a sandwich and half of a Uncrustable, like a sandwich with 2 pieces of regular sized bread, then I think half of that sandwich would be much bigger than half of the Uncrustable. So when we're talking about equivalent fractions, it's based on the same size whole. Okay? All right. So we are going to be thinking how many different equivalent fractions we can find for blank. And I guess as we reveal our problem string for today, we will see all the different fractions we're going to find equivalent fractions for. So let's begin with a very easy one. You know, problem strings usually start off more simple and then get increasingly more difficult. So let's start off with 1/2. How many different equivalent fractions can we find on a clock face of 1/2? So I'm going to get out my pen here, and we're going to make some 9s on this first clock. And I'm simply just going to draw 1/2. Here's my 1/2 piece. Y'all see it? Perfect. And I could shade it in very quickly, like so. All right, so what else is equivalent to 1/2? What happens if I were to cut this half-size piece into smaller sized pieces? What might I get? Ooh, did you say 2/4? Awesome. So I could separate my clock into fourths, and then I have still half of it colored in, same amount of space colored in, or since we're talking about clocks, it's the same amount of time that would have passed. All right, what else? Yeah, I could do 6, and so let me get my straight line. That'll look so much better. So I'm going to start off with thirds, because we know 1/6 is half of a third. So here's my thirds. And so I could color in half of this, which is how many 6? Awesome. So we got 1/2 as a fraction. We have 2/4 as a fraction. We have 3/6 as a fraction. I know we can come up with so many more. We're talking specifically about fractions you can see on a time clock. So maybe think about in terms of minutes. Even if I were to represent the same thing that I did on the first one, maybe instead of thinking about it in terms of 2 equal pieces, maybe I think about it in terms of how many minutes. How many minutes am I going to reach when I get down halfway? 30 minutes, right? So I could say this is 30 minutes, which makes my fraction 30/60ths, right? Perfect. Great job. Let's go ahead and look at the next one. How many equivalent fractions can we find for 1/4 on this clock face? All right, so I'm going to go ahead and label 1/4 here. Here's my fourth piece, and I'm specifically talking about this section right here. Y'all see it? Perfect. So we know 1/4 already, but I want to find an equivalent fraction for 1/4 on the clock face. What if I were to cut the fourths down into smaller size pieces? What would I get? Okay, so I'm hearing or thinking that I should be hearing two different things. That maybe you think about 1/4 and 2/8 being equivalent fractions, and they are. But if I were to split a fourth in half, and the fourth is 15 minutes, that's where we're landing on a clock. What's half of 15 minutes? That's not as easy to figure out, right? We could do it as 7.5 minutes, but it will be really hard for us to show exactly where that is on a clock. So I'm not going to represent that one, but I am going to represent the other one I'm thinking that you're saying when you're looking at this. Look at our tick marks on our clock. How many tick marks do we have in all? 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And if I'm talking about this small section, I've only gone how many of those tick marks? Good. 3 of the 12. So 3 12s. So here's a 12, here's a 12, here's a 12. I have 3 1/12 size pieces. What else? Let's think in terms of how many minutes we are talking about. How many minutes have passed? I just told you over here. And then how many minutes are in one whole clock? 60 minutes. So now I have 15/60ths. Did you get that? I hope so. And so I will represent it just by doing this right here. Talking about 15 minutes of the 60 minutes that are in the clock. All right, this next one, hopefully you guys can do on your own, because we talked about 1/4 just now, which means you should be able to figure out, or hopefully are able to figure out, how many equivalent fractions you can find for 3/4. So if we know 1/4, can you find 3/4? Go ahead and pause this video and work it out. And when you come back, I'll have the answers that I'm hoping that you were able to find. Okay, so did you get what I got? We know 3/4, and I just wanted to show you 3/4 is 3 1/4 size pieces. And that makes, hopefully, the connection here very simple, since we're talking about 12s here. And if you want to see my 12s represented, I can show them to you by separating a fourth into thirds. So I have 3 12s plus 3 12s plus 3 12s, which gives me a total of 9 12s. And then the last one, very easy. When I go 3/4 of the way around a clock, I land at 45 minutes, which is on the number 9. That stands for 45, because 9 times 5 is 45. Then I get 45/60ths. We good? All right. Next one. It's getting a little more challenging, but you can do it. I want to know the equivalent fractions for 1/3 on the clock face. 1/3. We know 1/3, and I'm going to show you 1/3 just like I'm showing you all the other fractions. Here is third, because we know a third is equal to how many minutes? We've done this, guys, 20 minutes. So I have to go to that fourth mark, which would be a 4 on a regular clock. Here's a third. What can we find out from thirds? From thirds, we can get sixths, right? If I separate my third into half, because a sixth 1/6 is half of 1/3. So now I have 2/6, which is the same thing, takes up the same amount of space. It's equivalent to 1/3. All right, what else can I do? Can I break up my 1/6? Absolutely I can. So even if I started off with thirds and then went to 6, or maybe you just started with 12ths right off the bat because you know that there are 12 numbers that go around the clock. See, this would be 1, that's 2, then we have 3, and then 4, and then 5, 6, 7, 8, 9, 10, 11, 12. So if I want to take up the same amount of space, I would have to go to the same distance, which would be to this 4, which really stands for how many minutes? 20 minutes. I'm going to color in the same amount of space. And what's my fraction here? 4/12. All right, there's one more that I'm thinking about that I hope you guys are too. We did in all these other ones, we have how many minutes out of 60. So how many minutes out of 60 will we go if we land here? How many minutes is that? Right, it's 20 minutes, which means I have the fraction 20/60ths, 20/60. Very good. Can you guess what's going to come next? I went from 1/4 to 3/4. Now I'm going from 1/3 to, you got it, 2/3. If you know 1/3, you should be able to figure out 2/3. So pause this video once more and go ahead and solve it. All right, did you get them? 2/3, because 1/3, 2/3, okay? And in 1/3 we have 2/6. So in 2/3 we'd have 4/6 because it's 2/3 plus 2/3. And then 8/12, and maybe I should have used a different color to outline it, but that's okay. And then we have 40/60ths. You guys got it? You good? All right, we have one more for our problem string, and then I have maybe a few more questions for you. So let's go ahead and finish this very last one. Now I want to know for 1/6 of an hour. 1/6, all the equivalent fractions you can think of. Good, let's look up here from what we found out before. Here is 6, so we know a 6th and a 12th. How many 12ths though? Good, 2 12ths. So we got 1/6, and we have, and just for the sake of time, I'm not going to represent them for you for this one. And then, so 1/6, well, I am going to represent it. I'm just kidding. I'm only going to represent the 6th fractional piece though. And then here's the 2 12ths. Right? And how many minutes is that out of 60 minutes? It's 10 minutes. So 10/60. Okay? And we can see that just by doing what we did here. We've gotten to 10 minutes. All right, so we're talking about equivalent fractions. Let's look back at what we found for 1/2 today. And it looks like we already have them in order from the fewest number of parts to the most parts. And hopefully you notice that the numerator is half of the denominator. Anything that's equivalent to half the numerator is half the denominator. And then we have, let's look at 1/3. And these are also in order from the smallest number of parts to the most number of parts, okay? So we're going to continue talking about equivalent fractions, but we're probably going to use a different visual model when we do our next problem string. But it'll have the same general idea or general concept. Thank you guys for working with me today. I hope that you worked hard. You made the effort to really think about these equivalent fractions in relationship to this clock, and that you are ready for our next number corner activity. Have a great rest of your day. See you tomorrow. Bye-bye.